Hey everybody, I am standing in the middle of a Bay Area legend, a legendary Bay Area location. One of the best maker spaces in the country is here in Oakland, California, and it's called the Crucible. If you have a hankering to learn something, to make something, this is where you can come satisfy that hankering. You can work with steel and learn welding, MIG, TIG, oxyacetylene. You can do cutting, you can do sculpting, you can do foundry casting, you can do glass blowing, neon work, jewelry, pottery, woodworking, wood turning, and I'm still probably missing half of the stuff they can teach you here. We're here today to check out a workshop in the electronics and kinetics department. Now, I've often pointed out that coders don't always think of themselves as makers, and I'm here to tell you, coders and non-coders alike, coding is making. And Acer has graciously donated laptops to the electronics and kinetics department in hopes of getting kids interested in STEM and looking towards the future. Let's go check out the class they're teaching right now to some kids in the electronics and kinetics department. The class that's being taught today in the kinetics and electronics lab is pretty straightforward. There's some Arduino boards, some Acer computers, and some LEDs, and the kids are learning simple programming to make those LEDs light up in a specific color.
My personal goal is to, bring this into kind of the 21st century. These kids, because they can program, why not? And they can still learn these electronic concepts, but they could just be cooler, because then now they can start doing things on their own with this little brain board.
Right.
And oftentimes kids are trying to do something like that. They're like, I want my light to turn on when I touch it and then turn off when I touch it again. Yeah, you can do that with some crazy IC flip-flop circuit. We could beat our head against the wall looking at the data sheet, or we could just program it.
Yeah.
And it's just way easier.
Easy input, easy programming, easy output.
Exactly. So just getting the kids program kind of a little bit more into the future. Amazing opportunity with having some computers. Yeah.
Shall we check it out?
Yeah, let's do it.
All right.
Yeah.
This is really great. On its face, these kids are just learning how to light up an LED. But what they're really learning is that a computer is not just a black box that you put stuff in and stuff comes out. They're learning how that process actually happens. And this is sincerely making. It's peeling aside the curtain of the world and understanding how it gets put together. Nate, how is the class going in there?
I think it's going pretty well. None of these kids have done any programming or electronics ever before in their lives.
So they're blank slates.
Blank slate, they've done nothing.
I saw a lot of lights lighting up.
Yeah, well, it's you got to pick like a project that they can quickly dive into. Mm-hmm. So something like an RGB LED is kind of fun because they're like, oh, I can like mix the colors depending on what I'm programming. It's picking something that like has some sort of immediate result.
How do you see this impacting the program moving forward?
It's going to be huge. We all are stuck in the analog electronics world, so now that we can start implementing electronics and our digital electronics just at kind of a front stage, because we teach kids how to use RGB LEDs anyways, but It's kind of more like testing out the different resistors to change the colors versus versus doing programming, which is kind of, I think, cooler.
I love the idea that they're learning that these things aren't black boxes.
Yeah, they're not black boxes. They're these like fast, intuitive things that you can kind of just mess around with, Like, I left the classroom, I was like, come on, just do it, And yeah, it's great. Or I asked, I was like, do you guys like math? And they were like, sort of, maybe a little bit. And I was like, well, we can use math to, make these things do things. So that's what's important to me, is kind of breaking down those boundaries of what math could be or what science and electronics could be.
Right.
Yeah.
Nate, thank you so much for letting us into this process.
Thank you so much.
Taking us around.
Absolutely.
Thank you, man.